Yes, guys. Good evening, one and all. Yes, join fast, guys. Yes, hope the audio and video is perfectly fine. Okay, guys. Yes. So let's start this session from BioPoint. Here, today in this session, we are going to start a new chapter that is from plant physiology, that is plant growth and development. Hope the audio and video is perfectly fine. And we are moving on to the one shot series of plant growth and development. And everyone watching this session should have your NCRT right in front of you because this session is gonna purely based from NCRT. This session is gonna purely based from NCRT. Each and everyone watching this session should have your NCRT right in front of you. Once again, if anyone new is watching this video, reminding you to join the Telegram group where there is daily session updates, regular discussion, daily polls, and you all can interact with me. t.me/neat underscore biopoint. This is the direct link to join the Telegram group. So, guys, spot it right now and join the Telegram group right now. Okay. So once again reminding you, do hit the like button, do share it with your friends, do subscribe the YouTube channel BioPoint Stream the World of Bio, and remark us by giving a comment in the comment section. So hope you all are perfectly ready for this session, and we are gonna start this with the full Josh. We are starting plant growth and development from the plant physiology unit, plant physiology. Okay, guys. Yes, good evening, Calvin. So let's check it. As you all know, in the first page of your NCRT, you can see this sentence, exactly the sentence that is, all plant cells are descendants of the zygote. Oh my god, what is this thickness? All plant cells are descent of zygote, that is the fertilized egg. The zygote develops into mature plant through growth and differentiation, forming roots, leaves, branches, flowers, fruits, and seeds, and they eventually die. This is the beginning given in your NCRT, and we are going to start this chapter purely based from your NCRT. So, first of all, before moving on to this session, take your NCRT and check the first page. You can see what this development is. What this development is. As you all know, this development is the sum of two processes. Development is the sum of two processes. Right. Development is the sum of two processes, that is the growth and differentiation. So this growth and differentiation together form the process known as development. And the first step in the process of plant growth is what exactly? It is germination. Exactly, the first step in the growth or plant growth is known as what? Germination, seed germination. So what is this germination? What is this germination? Exactly, the breaking from the stage in which the plant breaks its seed dormancy and it starts to grow up. That is what is said to be the germination, the seed germination. And in the same way, the plant starts its germination. Is anyone watching this session? 3 is shown here. Is there anyone? Comment me right now. So, and the seed germinates when it gets suitable conditions, suitable optimum temperature, optimum water to break its seed dormancy, optimum sunlight for it, for the plant, or for this for the young plant to grow. All these things, when all these conditions become suitable, the seed starts to germinate. Okay, when all these what becomes suitable, the seed starts to germinate. So in the same way, what we have to discuss first is that the germination, the germination in one second, guys. The germination in plants is of three types. First one, it is the epigeal germination. Epigeal germination. Second one, it is hypogeal germination. And the third one, out of all these two, we have a type of germination known as vivipary. Vivipary. Okay. Okay, Galvin. So, epigeal germination refers to that the cotyledons the cotyledons come above the soil. The cotyledons come above the soil, and then it is known as epigeal germination. Hypogeal germination, the cotyledons stay below the soil. Vivipary is a different case that we will discuss. So, cotyledons stay below the soil, remain below the soil. This is what is said to be what hypogeal germination. Then, where this epigeal germination is seen? Where is this epigeal germination seen? Where is this epigeal germination seen? Epigeal germination is seen in most of dicots. Most of the dicots. And hypogeal germination is seen in most of monocots. Most of monocots. So this is all about epigeal and hypogeal germination. Then what is this vivipary? What is this vivipary? That means that the seeds germinate while it is still attached to its parent plant. Why the seeds germinate while it is still attached to its parent plant. Yes, Calvin, it is out of your NCRT. Yes, it's out of your NCRT. But this is asked for your NEET examination few years back. Epigeal, hypogeal, and vivipary. Vivipary especially is asked previous year. Okay, so vivipary means that the plant or the seed germinate. The seed germinate while it has remained attached to the plant itself. That is known as vivipary, and it is seen in case of some mangroves. So what is this mangroves? What is this mangroves? They are the plants seen in those marshy areas where there are breathing roots, that is the roots above the soil for proper respiration. Okay, Galvin, happy to hear that you have learned something new from me. Thank you. Hope the screen is perfectly clear because for me on the screen it is showing blurred. But whenever I'm getting the recorded of this live session, everything is perfectly clear. That's why I'm not at all worried about that. So that if it's not clear right now, after the live session, you can watch directly the recording, and right at that time itself, the screen is becoming clear for me in my screen. Okay, so now we are going to discuss about plant growth. We have said that development is of two types. It's a sum of two processes, that is the growth and differentiation, right? Growth and differentiation. So what is this growth? Oh, it's blurred. One second, one second, one second, one second. Let me close this. Let me close this. Sometimes it makes the screen blurred. That pen makes the screen blurred. Okay, fine. Okay, anyway, it will be fine soon. Just refresh. Just refresh. That's all. Okay, fine. So, what is this growth? What is this growth? Growth is regarded as the fundamental and conspicuous characteristics of living beings. Fundamental and conspicuous characteristic of living beings, and that is what is said to be the growth. Okay, so growth can be defined as an irreversible permanent increase in size of an organ or its parts or even of an individual. So what is growth? As per the definition of your NCRT, it is an irreversible, permanent increase, irreversible, permanent increase in size of an organ, in size of an organ or parts or an individual cell. Even if a cell enlarges its size, we can say that the cell is growing. Even an organ enlarges its size, we can say that the organ is undergrowth. Even part of a body, human body or any other organism, if a part increases in size, we can say that it is growing. Right? Right, guys? So it involves metabolic process that consume energy. So growth is accompanied by metabolic process that is given in your NCRT, that is both catabolic and anabolic process. All those lines that I am reading from NCRT, you should mark it. And what you should do is the extra points that about the germination that I have said, you should write it in your NCRT. You should write it in your NCRT. Okay, fine. So after completing this session of plant growth and development, what I need is that each and every concept from this should be clear, and you should not lose even a single score from this chapter. You should not lose even a single score from this chapter, because I'm gonna take this in a detailed lecture. If it's not gonna finish it today, I will be coming the very next day with the continuation part of this. Okay, because the slides that I prepared first, you can see we can see very soon that includes only phytohormones, and this is the additional one that I have made in order to make you thorough with this lesson. Because right from today right from 6 a.m. till 6:15, I hope so, till 6:15, you will be receiving polls in our group regarding the questions from the beginning part of this chapter. Polls of questions right from the beginning of this chapter. Okay, so next topic from the NCRT is that plant growth is generally indeterminate. So we have to prove that plant growth is indeterminate. That is, the plant growth is unique because they have the capacity to retain for unlimited growth throughout their life. So as you all know, the animal growth as you all know, the animal growth stops after some time. Right? After the animal reaches a certain age, the animal growth stops. Whereas the plant growth continues throughout their life, it is due to the presence of meristems. Due to the presence of meristems, the plant growth continues all throughout their life. Okay, next sentence that you have to mark from the NCRT is the cells of such merisms have the capacity to divide and self perpetuate. Capacity to divide, self replicating capacity, right? Self dividing capacity, and they have a capacity to perpetuate, self perpetuate. Is that clear? Is that clear? This form of growth where new cells are always being added to the plant is known as by the activity of meristem is known as open form of growth. So the growth of plant is in open form. So the plant growth is open form. Whereas now what I am going to compare with is the growth in animals, so that this topic will be completely clear for you. So that this topic will be completely clear for you when I am comparing it with animal growth. Okay, Calvin? Okay, Calvin? Hope it's not getting lag for you and hope it is perfectly clear. If I am taking more time from you, just comment at the spot on the session. Okay, so that I will move a little bit faster. So the animal growth, since it is plant physiology, it should be moved very slowly and each and every concept should be clear. Okay, because otherwise it will be bored as compared to animal physiology. Okay, so on comparing with animal growth is determinate. Animal growth is determinate. Animal growth is determinate. And we said that particulars particular parts of plants undergo growth at each stage, right? At each stage, particular parts of plants undergo growth. Whereas in animal growth, what happens is that growth is seen in all parts of the body. Growth is seen in all parts of the body. Growth is seen in all parts of the body. From that, we can say that there is a closed form of growth in animals. Closed form of growth in animals. Is that clear? Is that clear? Is that clear? So next, this diagram is given there in NCRT. This diagram is given there in NCRT, and now we are going to discuss about primary growth and secondary growth. So primary growth occurs due to root apical meristem and shoot apical meristem that causes the elongation of plants along their axis. Elongation of plants along their axis. Primary growth result in elongation of plants along their axis. In secondary growth, due to the presence of lateral meristem. In primary growth, root apical and shoot apical meristems are present. In secondary growth, due to the presence of lateral meristems, vascular cambium and core cambium cause the increase in girth of the organs. Increase in girth of the organs. Okay guys, this is about all about primary growth and secondary growth. And the shoot apical meristem and root apical meristem as shown in this figure, as shown in this figure, as shown in this figure, the shoot apical meristem and root apical meristem helps in primary growth, and the vascular cambium helps in secondary growth, Is that clear? Is that clear? Is that clear? Okay, fine. Growth is measurable. This is the next topic in your NCRT. Growth is measurable. Nothing more to learn from that. Growth at cellular level occurs due to the increase in amount of protoplasm. At cellular level, growth occurs due to the increase in amount of protoplasm. Increase in protoplasm is difficult to measure directly. It is difficult to measure directly. So certain parameters like increase in fresh weight, dry weight, length, area, volume, and cell number, all these are used. Fresh weight, dry weight, length, area, volume, cell number, all these are used in order to measure this growth in as cellular level due to the increase in size of protoplasm or the amount of protoplasm, right? So the growth or the instrument used to measure this plant growth is known as what? Can anyone say? It is an out of NCRT topic. It is an out of NCRT topic. Can anyone comment it? The instrument used to measure plant growth. Without wasting much time, I am saying the instrument used to measure plant growth is oxanometer. Oxanometer. Previous year question, previous year MCQ, please mark it. The instrument used to measure plant growth is oxanometer. It is used. Oxanometer measures. Oxanometer measures is used to measure growth of plant in 24 hours, each 24 hours. An oxanometer measures how much the plant has grown in each 24 hours or each day. It's okay, Calvin, it's okay. Whatever you have forgotten, whatever you don't know, that's why we are here in order to guide you. Okay, guys. So bookmark it. Oxanometer is the instrument used to measure plant growth, and this oxanometer measures the growth of plant in 24 hours. Okay. This topics, just leave this. Cell number, cell size, length, all those things, just leave this. How it is measured, what all is measured under this criteria is have been discussed there. Just leave that. Not important in the MCQ point of view. Next, we are going to learn about the phases of growth. The period of growth is generally divided into three main phases, that is the meristematic phase, elongation phase, and maturation phase. Very important, because if you check the polls that is provided for you right in the group from 6 p.m., you can see many questions from this phase of growth and growth rate. The graph of the growth rate, that is the growth curve. All those things are the focused area for MCQ. Focused area for MCQ. Okay. So meristematic phase. Meristematic phase. Each occurs in meristem at root apex and shoot apex. Cells in this region have rich protoplasm and large nuclei. Other thing that you have to notice in meristematic phase, cell walls are primary, thin and cellulosic with abundant plasmodesmatal connections. So just leave that plasmodesmata. You just learn these 3 points, that primary, thin and cellulosic. Primary, thin and cellulosic. Primary, thin and cellulosic. Say it twice by heart. It right. Elongation phase. It occurs in cells proximal to meristematic zones that have increased vacuolation, size, and new cell wall deposition. Increased vacuolation, size, and new cell wall deposition. Maturation phase. The cells move further away from the apex. The cells attain maximal size in terms of wall thickening and protoplasmic modifications. Attain maximal size in terms of wall thickening and protoplasmic modifications. Okay, guys. Other most important topic for me to explain is this growth rate, right? Yeah. Before moving on to this, let me explain this figure. In this figure, you can see the region marked A and B. The region marked A and B shows meristematic phase. The region marked A and B shows meristematic phase. So can anyone comment which is the elongation phase there? Which is the elongation phase? A and B is the meristematic phase. Then what is the elongation phase? Can you comment the alphabet? Can you guys comment the alphabet? Come on. Waiting for your replies. Yes. Yes. This C and D. By looking directly in this figure, we can mark that this C and D represents the region of elongation. Yes, Calvin, the region of elongation. And G, F, and E. G, F, and E represents the maturation phase. G, F, and E represents the maturation phase. Is that clear, guys? Is that clear? This is all about phases of growth. And now we are going to say about this measurement of growth. Growth rate. Growth rate. Now we are going to say about growth rate. Okay, so the definition of the growth rate itself is the previous year MCQ. The definition of growth rate itself is the previous year MCQ. Okay, but how? That you can experience while you are getting the polls. That's why I have included it today itself. So this growth rate, it is the increased growth per unit time. The increased growth per unit time is known as what? Growth rate. Okay, guys. So the growth rate may be arithmetic or geometrical. The two types of growth rate is arithmetic or geometrical. Arithmetical or geometrical growth rate. Yes, dear. It's okay. We haven't yet reached the most important or the core of this chapter, that is the plant growth. Sorry, plant growth hormones, phytohormones, so that you will be understanding, since we have begun this topic only right now, that is the growth rate. So now we are going to discuss about this arithmetic growth. Arithmetic growth. What is this arithmetic growth? So arithmetic growth, before moving or before explaining all this, we are going to say, I'm going to explain it from my concept. I'm going to explain it in my concept. Okay, fine. So we are taking two cells, one and two. Two cells we have taken, one and two. In this cell divides into further two, that is this one and this one. So that we can see that this cell undergoes growth and this cell just moves to de-differentiation. De-differentiation. Okay. That is, they lose their capacity to divide and they just move back. Okay. And from these two cells, this cells forms two further cells, and these cells just de-differentiate. That is, they lost their capacity to divide. In the same way, here too, this cell divides into two, this cell divides into two, this cell divides into two, and this just loses their capacity to divide, and this further divides and this loses their capacity to divide. This is all about arithmetic growth rate. Arithmetic growth rate is what I have explained right now. Out of the two cells, one undergoes division, while the other differentiate, growth, differentiate. It is what happening in arithmetic growth rate. Is it clear, guys? Is it clear, guys? Is it clear, guys? Okay, fine. So let's check what is given here for arithmetic growth. Yes, Calvin and Suja. In this, the following mitotic cell division, only one daughter cell continues to divide. Only one daughter cell continues to divide, while the other differentiates and undergoes maturation. Other differentiates and undergoes maturation. On plotting the length of the organ against the time graph, a linear curve is obtained. While referring the NCRT figure 15.5, as per the latest NCRT, you can see this linear growth graph. Okay, linear growth graph. A linear curve, we cannot say that curve, linear graph is obtained in arithmetic growth. Is that clear? And now we are gonna move with geometrical growth. We have just began this chapter only. It is just the beginning of this chapter. We have a far to complete from this with very detail. Right? So what is this geometrical growth rate? That's what we have to discuss right now. What is this geometrical growth rate? Yes, geometrical growth rate is nothing more than this. We are taking two cells similar to that what we have did in the other one, that is arithmetic growth rate. So in this cell divides into further two daughter cells, This 2 divides into further 2 daughter cells. This 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 divides into further 2 daughter cells. Again, each of this divide into further 2. Each of this divide into further 2. This is what we say to be geometric growth rate. Each and every cell undergoes growth. Each and every cell undergoes growth. And that is what is said to be geometrical growth rate. And that is what is said to be geometrical growth rate. Okay? Okay, guys? Fine. So on plotting the parameter of growth against time, we get a typical sigmoid S-curve. That is starting with a lag phase, then a sudden exponential phase, and then moving on to stationary phase. This is what all about geometrical growth. This is what all about geometrical growth. Okay. So, a sigmoid curve is a characteristic of living organism growing in a natural environment. It is typical for all cells, tissues, and organs of a plant. The exponential growth can be expressed as W1 is equal to W0 ERT. W0 ERT, where W1 represents the final size, W0 represents the initial size, R represents growth rate, G represents time of growth, and E represents base of natural logarithms. Base of natural logarithms. Is that clear? Is that clear? This is all about geometrical growth. This is all about geometrical growth. Okay, and this exponential phase or the log phase, exponential phase or log phase, log phase is the period of vigorous growth, is the period of vigorous growth. So here R refers to relative growth rate. It is also the measure of the ability of plant to produce new plant material or the efficiency index. Hence, final size, that is W1, depends on initial size, that is W0. Quantitative comparisons between the growth can also be made in two ways, that is absolute growth rate and relative growth rate. Absolute growth rate and relative growth rate. Absolute growth rate means measurement and comparison of total growth per unit time. Relative growth rate refers to measurement of the given system per unit time expressed on a common basis, that is per initial unit initial parameter. So now we are just going to discuss in detail what is this absolute growth rate and relative growth rate. Absolute growth rate or AGR. AGR. It means growth per unit time. Growth per unit time. Growth per unit time. Right? Growth per unit time. So, here look, you can see 5 centimeter and 10 centimeter. Right? 10 centimeter square, 5 centimeter square and 10 centimeter square. So, what is the absolute growth rate in this figure? We can see that is 10 minus 5. 10 minus 5, that is 5 centimeter square is the absolute growth rate. Here it is 55 minus 50, that is 5 centimeter square is the absolute growth rate. Whereas this relative growth rate is expressed in percentage. Relative growth rate is expressed in percentage. That is 10 minus 5, it's 5. So 5 by 5 into 100. 5 by 5 into 100. That is 100 percentage. Here the relative growth rate is here the relative growth rate is 5 by 50 into 100. That is 50%. That is 10 percentage. That is 10 percentage. Right? Right? So this is all about relative growth rate and absolute growth rate. Okay. Conditions for growth. Conditions for growth. Water, oxygen, nutrients, temperature, light, and gravity. These are the conditions for growth. Guys, I will join you soon. 1 second. 1 second. Guys, I have some urgent works to do. So I'm just ending this. Thank you all. Do hit the like button, share it with your friends, and subscribe it. We will join you soon.